Again, good afternoon to all. So today, I'm going to lay out the guidelines and policies for our laboratory sessions. So kung ato ta sa atong e-learn, if we go to our e-learn page, ibutan nga bago nga portal here for the laboratory. Ganyan ako ng morning na create. So if pwede nyo ma-visit ka ron, pwede ba? So if yung anahaan na siya. So gi-upload na ako ang file for our lab report. So ako nang ikon in a while akong go over. So attach is the file which lays out the format for the lab reports during to write out from the lab. Lab activities and simulations. For each new activity, simply add a new set of tables copied from the format page. So how does that look like? So kung ako i-open ang file, muna itsura. Makita naman, no? Maklaro naman akong screen na Microsoft Word.
Yes, sir.
Okay. Okay, thank you for response. So kanay mo ning itsura sa inyo hang lab report. So ako na ning create, iko na lang ni i-fill in. So here's the cover page. ECE 12.1. So i-change ninyo yung name dire. First name, middle initial, last name, ECE 2. So this will be the second page will be the table of contents. So pwede lang ninyo ni i-delete ng second na row. Kung ipasa na ninyo pohon, no? So pwede lang po delete, no? Wala na lang. Para pwede naman i-edit na 1 ni siya. Then it's 2. Okay. So if you could do that, puhon-puhon kung i-pass na or isubmit ninyo ni. No? So format. So we're going to perform siguro at least 10 simulations for this semester. So what we're going to do is just press tab para madungag-dungagan no? Experiment 2, experiment 3, 4, 5, 6, so on and so forth. Then pulian lang din yung title for the experiment 1 or 2 or 3. So on and so forth. So ang first na page dire would be the template or the format for each report. Okay, divided into 6 parts: objectives, context, circuit, measure data, observation, and conclusion. So kung ipasa ninyo, pwede rin i-delete na page. No? And, so the first simulation or experiment will be experiment 0. The objective of this one is to demonstrate Ohm's law with a simple electronic circuit and introduce the learner with LTspice. No? So experiment 0 ni siya. Diligid na siya officially sa list of experiments, but this is just to get the hang of using LTspice. No? So balik ko dire. Again, for each new activity, simply add a new set of tables copied from the format page. So let's say, for example, experiment number 1. Diba? No? So, what if experiment number 3? Okay, example, experiment number 3. Create lang new page here. And from the format ng page, i-copy lang ng table. No? Copy lang na siya. Then, butang dire. Sa new page. So, change na ako ni experiment 3. Experiment 3. Title. So, title. Ayan na. So, yan na lang. No? Kung magkuhan na taog bago na po na experiment. So, balik na dire sa experiment 0. So the objectives will be given kani this one, ako mag-provide ani. So, ikaw lang yung copy and paste. No? Let's say, for example, dala ako sa lab 0 here. Lab 0 Ohm's law. So, kaning nasa silong, sa bottom portion, that would be the objective. So, ikaw lang na siya i-copy, then i-paste lang direct. No? What's next after the objectives? But you're going to provide, the objectives will be given, but you're going to provide the context, no? Which will just be a short explanation of the underlying electronic theories and principles. So context, the title of this experiment is Ohm's law. So a brief overview lang of what is Ohm's law. No? So experiment number 1 would most probably be on diodes. So just right here, a small description on what diodes are, how diodes would work. No? That may have been discussed in the lecture. So pwede, ang inyong ibutan sa context is kung sa taught mga learn sa lecture. No? Pwede lagi po mo copy good ta sa mga sources nato sa internet, no? Textbook or wherever. So short lang, no? Dili mo na to objective nga i-discuss ang topic. Context lang. Okay? Context that governs the said experiment. It may be written after the experiment is done. No? So, pwede man nga ang context later na lang pag mahuman na ta sa activity. Okay. Later na huwag na natay idea kung sa giday ang experiment is all about. So, the circuit will just be a screenshot of the LTspice file. No? So, after the context, part 3 is circuit. No? So, kani, screenshot ni siya. No? So, print screen lang, then i-paste lang dayon. Oy, paste lang dayon dire. Ana. The measured data will also be screenshots after running the circuit. No? So, kaning circuit dito sa LTspice, I'm going to demonstrate it later. After pressing the run button, na run dito to perform the simulation or the analysis, muna mo gawas, no? Kani siya. What you're looking at right now. So, ikaw lagi apon i-print screen, no? No need to select and copy because I'm not sure kung makapigid ni siya nga file. So, print screen lang. No? After print screen, paste lang din dire. So, aside sa data of voltages and currents, dito po ibutang nga portion sa measure data ang generated waveforms, no? Only when applicable kung naa, no? Kung wala, okay la wala. Also, when calculations are required, no, manual calculations like solutions, they may be written down. Kung naa, no? So write down your observations. The next portion is the observations. Write down your observations based on the context and measure data. No? So, kibali, how will we relate the topic at hand, which is in the context and the data that yung nagather? May butas observation. No? Observation lang, no? Very short lang yapon eh. Could be a few sentences. Some, nga mas daghan slag na point out nga observations. A few paragraphs. No? So, like, necessarily minimum or maximum. And properly conclude the experiment. So how will we conclude the experiment based sa objectives? So again, ang observations is based on the measure data and context. What the topic is all about. And conclusion is based on the objectives. So mabuo lagi po ng conclusion. Okay? So I'm going to provide for the file. You're going to download just like this one, no? Lab 0 Ohm's law. If you're going to click this one, ma-download ang LTspice na file. So i-go na to i-open sa LTspice, then actually diretso na ni siya, no? You could perform this experiment or the simulation. The simulation proper at least. Few minutes lang, ma-produce na din ang data. Pero the right apps, of course, man, kinanglan mo gini tagan of time and effort ang pag-produce sa lab report.
Sir.
Yeah.
Free na ng LTspice, sir?
Yeah, free ng LTspice. So, Sige lang, ako gapong i-demonstrate later sa asa i-download sa pag-install.
Sige,
Pero
sir.
yes, to answer your question, free na siya. That's why mo na itong gigamit kay totally free siya. No? Unlike lugar, the closest na one of the best po yun nga simulation software nga pwede nato gamiton, which is not free, is Multisim, no? From National Instruments. Multisim. Chada gid ni, no? Very nice piece of software for not only simulation but for analysis also, for design of electronic circuits. So really siya free. Pero daghang mga installers nga makita nato sa internet, dili na nato na i-recommend yun kay hindi na siya good, no? Pero LTspice would serve our purposes, no? Okay, so with regard to na may mga initial questions, if ever man nga dili pa klaro, sige lang. I'm going to entertain questions magyapon as we go, as we progress through the semester, if ever na gid mo'y pangutana. Pero that's it, no? Basic lagid kayo ang inyong responsibility with regard to writing the lab report. So inyo lang i-provide diri is the context, the observation, and the conclusion. Almost everything, half of everything else is ako na nag-provide. Objective, ako ani. The circuit, igot naman ninyo na i-screenshot, kaya i-provide naman ako file. Technically, dili naman ninyo i-build yun ang inyong circuit, no? Kaya na naman ang file. So, may naka-nice pod. Measure data, igot na lang pod gyapon i-screenshot. So, ang heavy lang gito is ang context, ang observation, at ang conclusion. Okay, so that's for the lab report. Again, if ever na may question, ani, don't hesitate to ask me. No? Just message me on Facebook. And ako leave out nga part din. Ako emphasize now. The compiled reports will be submitted at the end of the semester. So I'm not going to check up on your lab reports every week. Okay. Kaya I intend na i-submit ninyo at the end of the semester nga. Nanatanan, no? Na na-perform na tanan nga experiments. With each experiment, not necessarily done each week man pod, no? You could do it in your free time. You could perform 2 simulations in 1 week. Kaya wala nyo na buhat ang last week, no? Pero it's recommended so that they won't pile up, no? I could recount students nga I have pag-perform tanan at the end of the semester, so bugat kayo. So mas better man ang hinahinay, at least pag-abot sa May, isa lang ka-experiment po ang inyong i-perform kaysa sa dito na nyo gitipon tanan. Diba? So again, the compiled reports will be submitted at the end of the semester. Pero almost more often than not, weekly siguro akong pag-provide sa inyong file nga i-simulate. No? So experiment 1 experiment 1 or lab 1 next week na. Kaya that's about diodes. Man, pumunta na-discuss on diodes. Yeah, so that's it so far. Bulletin board. Okay. So I'm going to now demonstrate how to download and install LTspice. So ito lang mo sa Google, no? Google, then just type LTspice, LTspice. Lang, no? I think kaninga laptop na akong ginagamit ka wala pang din siya na-installan. So it's better. I hope madawat niya ang file nga akong i-download, no? So just click the first link magawas, no? LTspice. LTspice is a high-performance spice software, simulation software, schematic capture, and waveform viewer, with enhancements and models for easing the simulation of analog circuits. included in the download LTspice are macro models of integrated circuits, no ICs, for a majority of analog devices. So ang developer right now of LTspice is Analog Devices. Pangalan na siya sa company, no? It's a relatively big pod na company. Dako ni siya nga company nga US based. But na sila planta diri sa Philippines na sa Cavite. So dako gyapon ni siya ang company. Producer of electronics and integrated circuits. So let's download LTspice. Kaning first one sila, I think, download LTspice for 32-bit.
Sir, Windows 11 na ba ko, sir?
The Windows 11.
Wala, na accidentally upgrade ako kung laptop, sir, ba?
Try lang, pwede man siguro.
Sa kanang 64-bit, sir?
Kung unsay nga bit inyohang computer, mo pud inyong i-con, of course, 64 32.
Sige, sir.
So wait lang sa ako sa tanawon sa nga bit ning akong laptop karon. Okay, 64-bit day siya. So 64-bit man akong laptop, I'll just download this one sa middle. Kung inyong laptop is 32-bit, so kaning 32-bit of course. Kung wala naman sila mo saan pag-determine kung 32 or 64 yung mga laptop, no? So, balik lang no? Bubo naman siya, 57.8 megabytes lang. Balik lang na ako. Okay, so ano siya? Accept. So, dili nga folder siya mo install. Install now. I think dali naman no? Okay, LTspice has been successfully installed. Okay. No lang sa. Okay. So, muna na siyang interface sa LTspice. If you're going to use LTspice for your own analysis of simulation, you could create a new schematic. Click lang yun yung icon. Diba? So, nadiri ang mga components. So, diri nga parts taskbar. So, add wire, ground, label, resistor, capacitor, inductor, diode, components. So, if I'm going to add a voltage source at the component, so kamo na ba mag-explore sa uban pang no? Component mga more complex siguro or dili kayo commonly used, pero of course ang gamiton kay voltage source man gid. So, voltage source is here. Again, click lang nako ni ato component, mark end gate siguro ni, and type voltage, the voltage source. Okay. Escape lang para wala to siya nga symbol. Resistor, diba? Then resistor, Control R, I think, for rotate. Lagay Control R for rotate. Then escape. Always place a ground sa any circuit ng inyong buhaton. No? So, wala akong ground. And then, so akong buhat karon is a simple na voltage divider na circuit. Okay. So ako na siyang ipang wire. Click lang ako ni wire. Point and click lang. Click, click, click. Okay, so this is my very simple na circuit. So no matter how simple or complex, yan nila magiging ang method. Change ang mga values. To change the value, hover lang mo sa schematic symbol, then right click. So let's say, for example, 10 volts. Let R2, R1, you know, let R2 be 7 ohms, example. R1, 3 ohms. So, using voltage divider theorem, we know na ang voltage across R1 is 3 volts and the voltage across R2 is 7 volts. Pilay current nag-flow. 1 ampere? Sakto? 1 ampere ang flow sa circuit na to?
Yes, sir.
Yeah. Okay, sakto 1 ampere. So how am I going to check the values of voltages and currents? So after building your circuit, after wiring things up, wiring the components, and again, don't forget to place a ground. So next step is to analyze or run the simulation. So na icon dire of what looks like a person running. So just press this one to run the simulation. So natay 1, 2, 3, 4, 5, 6 types of analysis na pwede perform. Transient analysis, AC analysis, DC sweep, noise, DC transfer, and DC operating point. So for basic analysis of determining the voltages and currents, the DC operating point would suffice. So just click this one and click OK. So again, ato ko aning icon nasa upper left. Press this one, run, and then ato sa kaning tab DC operating point o DC OP point, and click OK lang. So and that's it. Tara, nagawas na ang mga values. So voltage of node 001, i-assign na siya ni LTspice as this node, the node of the positive terminal of the voltage source. Of course, 10 volts. 10 volts. Voltage at node 002 is, I believe it's this one, the intersection of the terminals of R2 and R1. Or kung sa ato pang circuits, voltage across the load. So yes, 3 volts. 3 volts. So muna ang mga current. Current across R2 is -1, meaning kung mo lang convention yan, electron flow. So positive ang padulong sa source. So away from the source is -1. -1. So these are the currents. Okay. So pwede na to idungagan pa og mga resistors. Let's try to add some more resistors para kuan. Just to demonstrate its capability. So let's say, for example, this one is 15 ohms. Kanina, let's say 1 ohm na siya. And 5 ohms. So this might look something like the kind of circuits ngayon na encounter sa circuits one before, no? Solve for the device. So solve for the current across all resistors and the voltage current through all resistors and voltage across all resistors. So yan naman usually. So you could manually solve this one using nodal analysis or mesh. For LTspice, is lang ka-click, just click the run button, and the DC operating point will perform na niya. So automatic na. So man yung mga voltages. This one. Node 2, kanila gihapon, I believe. So si node 3 is this node right here. And these are all the device currents. So, diba? Current across current through R1, 0.88 milliamperes. No, 0.88 amperes din no? Amperes. 1.05 ampere, 0.167 ampere. And this is the total current sa atong circuit, 1.05 ampere. May gagawas ni V1, so may siyang total current. Yeah. Okay. So that is if that is if gamiton ninyong si LTspice for your own simulations, or if ever na mo gusto i-check na kuan, no, i-check na manual ninyong solution or assignment baka, no. So for us sa atong mga laboratory experiments, the circuit files are already provided. So ganun to i-download, no. So balik ta sa atong e-learn page. Tara, for example, lab 0, Ohm's law. So kung i-click ni, download siya. Tara, no? So this is lab 0, Ohm's law. So na-provide na ang mga circuit file. You don't need to build this circuit. So na pre-made na siya. So kung na pre-made na, just click run, DC operating point, click OK. Dala na inyang, wala lagi. Kasi kulang ani. 0 to na, no? So na something wrong. Okay. So si voltage source na ko is wala pa value. So let's say 5. Ito, run. So dala, no? I think mo coincide din siya sa katong nasa lab 0 sa file nga akong i-open earlier tong sa Microsoft Word. So mo ni siya nga mga kuan values. So that's it, no? That's the hard part na sa simulation. Kaya na naman ang file, igon lang i-run. Okay? Igon lang ni screenshot kaninga circuit, no? And ang data. Paste na dito sa Microsoft Word. Okay? Now,
Kami na mag-connect ka na, sir.
Actually, na-connect na siya. No? Wala na ni, din na siya.
Icon pa na.
Connected na ni. So, ang gibuhat sa original ng author ani is na para isa lang iyahang voltage source, nagamit siya aning component label, no? Input label. V1 example lang. V1. Lagi. V01 example. So yan yung i-connect dire sa voltage source. para ang mga wires or components nga kung asa niya i-connect dire, pareha lang sila og label. Notice nga ang atong voltage source is connected sa V+, no? So kanipod ang next nga resistor R1 connected pud siya sa V+. It's as if connected ni sila, no? The same sa kaninga circuit here, no? Sa diode. This is a diode man, this one. So si diode is connected kay V+. Diba? So para I don't know sang advantage gid ani ultimately, but naka-save siya og number of components kang gibutang instead nga duha ka voltage sources. Anyway, pareha man sila og values. Isa lang ka voltage source. Gibutang lang yung mga port. No? So you could also do that sa inyong mga future simulations or sa inyong mga exercises nga i-check ninyo. No? One question that's sometimes brought up is, sir, pwede ba may magpuli-puli o values, no? So example ani 470, no? So again, ang objective ani nga particular experiment is to demonstrate Ohm's law. So wala man siguro madaot, no, sa pag-achieve sa objective if pulihan ako ng mga values. So pwede ra, no? At kung values man lang galing, no, pwede ra pulihan ng value, no, for 500. No? Kani siya ay mga to 1K. Then simulate. So muna nila yung mga new values. So pwede ra i-change, pulihan ninyo mga values nga musut sa inyong liking. Pero i-provide lang po dito i-note lang dito sa observations niyo nga I have tried to change the values and this is the outcome. Yan. So ang di lang siguro pwede is ipulihan ang mga component kay mo maging mga components atong paggamiton. Yan. So pwede ba ko magdungag what if ka to, no, out of curiosity pulihan niyo yung mga component or namoy dungagan ani. So pwede ra, no? Wala problema. Outside na siya sa atong objective. Inyohan na siya nga all na curiosity, pero you could do that, no? So what if maguba ko bali ang file? Okay ra kay download lang ko download ang bago, no? I-delete lang yung daan. Download ang bago. So you could do pretty much any kind of experimenting that you want, no? Wala may mga sunog na components if ever nagintay ma-save dire, no? So that's the beauty of simulations. If ever nagintay na sayop og encode na value or whatever or na save tag wire, di man to mag-expect na masunog atong computer, di ba? So little lang po nga detail. Actually, this is the first step to the face-to-face na face-to-face na experiment. Sa actual na laboratory, before nato ni i-build na circuit using actual components, using actual voltage sources, using actual oscilloscopes and meters, no, multimeter, i-simulate sa nato, no, para perfect. Para pag-abot sa real components, dili ta mag-expect na yung mga sunog sad ng mga component, no? So pero tungod kay online naman ta, I guess tama lang dili atong experiment. Di man to baka perform o build ani using breadboards and actual resistors and diodes kay dito lang to sa lab pwede buhaton, no? Yeah. So this is the circuit for lab 0. If you have any more questions related sa actual na performance ani, you could again message me anytime. Any questions?
Answer.
So far? Ada ba di? Wala.